everyone, welcome to Graphing Practice Good vs. Bad Graphs. So in this set of notes, we're going to work on figuring out what makes a good graph, how are the graphs that you make in science this year going to be graded, and then we're going to try analyzing some graphs to see if they are good or if they could be improved. There's some slides kind of near the end that you'll have to write some notes in, which is why I'm going to have you submit these at the end. But for the first several slides, there's nothing actually to write. So first, we're going to start with what is a graph. So number one, a graph is a visual display of the relationship between variables. Usually there's two variables, your independent and your dependent. We've talked about that a lot. Number two, it helps scientists to analyze the data after an experiment. So once you collect all of your raw data or the kind of unanalyzed data, you want to organize it in a way that can help you kind of make sense of what you figured out in your experiment. And then number three, it's the main skill tested on the ACT science section. And so being good at graphs and kind of knowing how to look at a graph and know what it's trying to tell you is a super important skill for just like life in general outside of school. There's a lot of instances when you'll have to look at data and figure out what it's trying to tell you. So this is good life practice. Some things to remember: a good graph must include the following things. There's 5 of them. 1, a proper title. This helps the reader to know what they're looking at. The title should include a detail about both of the axes. So it should include something about the x-axis and something about the y-axis. Number 2, it should have labeled axes. So the independent always goes on the x, which is the horizontal axis. And then the dependent variable, the thing that you are measuring that changes because of the experiment, that's going on the y-axis. It's the vertical one. Number 3, a graph should always include units. In parentheses, example kind of on the right, height, and then the units are in the parentheses, right? So if you are trying to show the height of something, you have to include the unit. Otherwise, we don't know, are you talking about centimeters? Are you talking about miles? Are you talking about feet? What is it, right? Number 4, it has to have a key. This is only if you are, this is only in some cases. So if you're only graphing one line, so one set of data, you don't need a key. And then number 5, you must have a good scale. Your graph should fit the entire chart. So if you are graphing and say your x-axis goes all the way up to 100, your y-axis goes to 100, but then all of your data points are just like somewhere between like 0 and 10, your graph is going to be really small. So you want to actually change your scale so that the graph fits the entire chart and it's not just this tiny little thing in the corner. Here, we're going to talk about 4 main types of graphs that we're going to be focusing a lot on this year. The names of them are the bar graph, the line graph, the pie chart, and then the scatter plot. The hardest part is deciding which to use and when to use it. But here are some general hints. So the bar graph, there's a picture of it down here. And this is used to show discrete data. So there's no in-betweeners. So it's just when you can't have like a portion of something. So in some of the classes I had talked about, like if you were talking about how many students per class, you can't have half of a student, right? So that would be a discrete data point where you just have whole numbers, right? This example, it looks like it's talking about different types of fruit, right? So you have each line as a different type of fruit, and you can't have like half blueberry, half strawberry, right? So it's discrete data. The line graph, this is used to show continuous data. So this is the opposite of discrete. And this is kind of when you can have those in-betweener data points. So like a continuous time frame might be a good time to use a line graph, or honestly like heights of like people in a room or something where you can have a bunch of different heights. That kind of thing is continuous. The other 2, we've got the pie chart. This you usually use when you're showing the percentage of a whole. Does not show change over time. So this one is not good to use if you're trying to show change over time. The scatter plot is the last one, and this one shows the correlation between two variables, but it doesn't necessarily make a line. So this is when you have a bunch of different data points, and you can kind of see a trend between them sometimes if there's a correlation, but there's not necessarily a line between all of the data points. You can see in the picture that when it goes kind of up at this diagonal, we have a positive correlation. If it's going down here like this, you have a negative correlation. And then if they're just all over the place, you can tell that there's really no correlation between the two variables. So here's the grading rubric that I'll be using to grade your graphs in science class this year. It's pretty straightforward. I'm going to look to make sure that you have a graph, or sorry, a graph title. Your title should give kind of an accurate idea of what you are graphing, and it should include the X and the Y axes, some sort of detail about those. I'm going to look at the X-axis title, so make sure that you are actually titling or labeling the X-axis, same with the Y-axis. I'm going to look to make sure that your intervals are equal, right? So you shouldn't jump from like 2 to 7 to 8 to 15, right? You should have even intervals on both the X and the Y. This is just a yes or no. And then lastly, are you using the appropriate type of graph? So basically, does the graph used easily make sense of the data, right? If not, you maybe used the wrong type of graph, and a different one would have been better for analyzing. For the analysis, I just wanted to point out this highlighted part. So this is when you do a formal lab report, you're going to be graded on your analysis section. And this is kind of the important part that I want to point out. There's at least one graph that accurately displays the data. The graph created helps find patterns in the data. The patterns help to determine if your hypothesis was right or not. So if you're graphing something and it doesn't have to do really with your hypothesis or your question, that's going to be a problem. And so be sure that you're graphing the information that will help you determine if your hypothesis is correct, which will help with your analysis section. All right, so let's analyze some graphs. It might help to have the rubric up on the screen as you're doing this. And for these next few slides, you will have to pause this video and write some things down on your notes. First question, what is good or not so good about this graph? Go ahead and pause the video and write some things on the side about things that are good or not so good. All right, hopefully you paused the video. Some things that I'm noticing right off the bat that are good, I guess, are that there's even intervals on the y-axis. So it goes 0, 10, 20, 30, 40, 50, 60. A thing that maybe is not so good is that on the bottom, we skip, it looks like we start going every one. So 1, 2, 3, 4, 5, but then we skip 6, we skip 8, we skip 10. So the interval on the bottom is not so good. I'm also noticing that it looks like we have labels for the X and the Y axes, which is great, except that there's no title. So that's a little bit frustrating. There is a key. However, the key is really confusing. There's a lot of colors. There's a lot of things to look at here. So we have this bar graph, but also the scatter plot, and it's all mixed into one. So I think that there's just too much information on this graph, and it doesn't make it clear about whether or not there's a pattern or what exactly even we're supposed to be looking for. So I would say that this graph has more negative factors than positive. Hopefully you had some of that stuff. If you didn't have any of that stuff written down, go ahead and pause this video again and add to what you had written. So here's the second graph. It says, if we listen to music, then our pulse will increase because. So we have this graph here to show the data that was collected. And the question is it easy or clear to tell if our hypothesis was correct? Go ahead and write your answer. Okay, so hopefully you wrote either yes or no. But the thing that I wanted to really point out here, this is getting us back to that question of are we using the correct graph to show what we really want to show? And here, these data points are so close together that it really is difficult to tell whether or not we can, whether or not our hypothesis was correct or not. So I would say that it's not very clear to tell if our hypothesis was correct, just because the data points are too close together and we can't really analyze it very well. So here's a different graph. If we don't use a line graph, maybe a bar graph would work. And so go ahead and take a look at this graph, pause the video, and write down, is it easy or clear to tell if our hypothesis was correct in this case? Okay, hopefully you paused the video. And for this one, this again is kind of difficult to tell. These data points are really close together. Some of them we have the resting pulse rate a little bit higher. Some of them we have the music pulse rate a little bit higher. And so again, it's really difficult to tell with this bar graph. So I would say no, it's not very easy or clear to tell. So then here's the third and final graph. It says, this graph shows the average pulse rate when listening to music and not listening to music. So is it easy or clear to tell with this one? Is it misleading or is it clear? Tell me why. And then is there anything missing from this graph? Go ahead, pause the video, and try to answer those questions. All right, so hopefully you have answered both of these questions. I would say that yes, this is much more clear. We've taken the average of all of the data that we've collected, and now we can tell that the average resting pulse rate is about 80. The average music pulse rate is 85. So there is a little bit of a difference here. If we were going to say that it's misleading, it might be misleading because our intervals starts here at 77, so it doesn't start at 0. And so if we actually made it start at 0, this difference would look a lot smaller because really it's just an interval of 5 that is the difference, but it looks like a huge change. So that could be misleading. But if you really look at the intervals and you look at the data, it is much more clear. And if you look into it, it's not quite as misleading as you might think. Anything missing? We are actually missing the label on the y-axis. And so be sure that you're not forgetting to do that. We have our title in there. We have the x-axis labels, so everything else looks good. All right, congratulations on finishing the graphing notes. Now you can go ahead, submit your notes to the Dropbox so that I can tell that you answered the questions in here, and you can go ahead and complete the graphing fun sheet honor style. Feel free to Schoology message if you have any questions at all.